Chapter 4, Measurement Systems, Units, and Equivalencies. So we'll go through the terms and definitions throughout the chapter. And we're going to skip past this pre-test. Again, this is not required unless it's an assignment for you in Canvas. 3 measurement systems are presently used in the medical field to calculate length, volume, and weight. Although length is not commonly used in the pharmacy field as in other medical disciplines, each system has a unique set of measurement units that have been chosen as standards. Numbers without units are meaningless. So that right there is a very important statement in pharmacy. So when we are doing our answers, we want to make sure we're always putting units. Without units, we have no idea what you're talking about, what you're ordering, what you're filling, anything like that. The U.S. customary system or the household system, that is what we currently adapted in the U.S., uses measurements such as inches, teaspoons, and pounds. The international system of units of the metric system, which is used in most of the remaining world, uses meters, liters, and grams. So that is what we use in pharmacy, the metric system, meters, liters, and grams. The apothecary system, which uses grains and drams, is an older system used in pharmacy for many years, but less frequently today. So all 3 of those are used in the pharmacy. They have units of measurement for weight and volume that are used in pharmacy, but only household and metric systems have commonly used units for length. So there's no length in the apothecary system because, again, we don't use length very much in pharmacy, and that was developed a very long time ago. So you could get prescriptions with all 3 of them on the prescription. You can get it all metric system. Usually isn't sometimes like for liquids, it'll be like household and the metric system. So in pharmacy, when we do use length, we use it to measure medications that require application to the body that must be measured in inches, centimeters, or millimeters. In this instance, the means of application is usually pre-marked on a dispensing paper for ease in ensuring that the correct amount of medication is administered, such as with nitroglycerin ointment. Another pharmaceutical use of length is in finding body surface area, where weight and height are used for dosage calculations, which we will be covering in chapter 12. Mass is the measurement of the amount of matter in an object and is commonly referred to as weight. Metric weight is the measurement used most often in pharmacy to express a dosage unit. Most medications are ordered and supplied by the weight of a drug in solid or liquid amounts. Most solid medications are supplied in micrograms, milligrams, or grams. A few older medications are still supplied in grains from the apothecary system. Household measurements of weight are not used in medication strength. Volume is the amount of space something occupies, and it is used to measure amounts of liquid. A derived unit that is used to describe liquid medication strength is density, which is weight divided by volume. Most liquid medications are described in terms of milligrams per milliliter. Occasionally, some products, such as milk of magnesia, are still labeled with the amount of active ingredient per tablespoon. Some other specific types of medications that we dose in are milliequivalents and international units or units. Milliequivalents are used to express concentrations of electrolytes that are needed for normal body functions. For example, K-DER, which is potassium, 20 tablets contain 20 milliequivalents of potassium per tablet. Unit as a measure are assigned to various biologicals, which are substances made from living organisms that are used therapeutically as medications. The unit measurement is actually assigned to a medication's activity in that system. Units are specific to each individual medication and they do not relate to one another. For example, units of insulin cannot be compared with units of heparin. Measurement of these two medications are going to be covered in Chapter 11. Most measurements need a unit to have a meaning. The one exception to this is specific gravity, which is the density of a substance in grams per milliliter divided by the density of water, which is 1 gram per milliliter. We use specific gravity occasionally in pharmacy to calculate the weight or volume of a solution. And we have a tech note here. The Joint Commission has a do not use list. On that list is the use of U or U, which should be written as unit or IU. So they recommend that the doctors don't use put 20U because it can be mistaken for 200 or 206 or something of that nature. But they're still going to do it from time to time. So just keep that in mind. So the household or US customary system of measure is being introduced first because much of it is already familiar. Household measurements and abbreviations of weight can be found in table 4.1. So for our household measurements of weight, we have ounces, pounds, and tons. And these are the abbreviations. And here's some equivalents between the three. 4.2 has household measurements of length, so inches, foot, yard. And we have inches, feet, yard here. Table 4.3 has household measurements of volume. So we have drops. The abbreviation for that is GTT. So hopefully you guys have been studying your SIG codes. I recommend knowing those before the math mod or during learning them at the beginning of the math mod, because it's going to make it a lot easier for you to do the math problems. Teaspoon is TSP. Tablespoon is TBSP. Ounce, OZ. Cup is C. Pint is PT. Quart is QT. And gallon is GAL. Household measurements are expressed in Arabic numerals with fractions for expressing parts of a whole, such as 1/2, 2/3, or 3/4. The abbreviation for each measurement follows the number. So, for example, 5 teaspoons or 2.5 pints. So with the household system, if our number doesn't come out to a whole number, it needs to be expressed in fraction form. And we'll do some examples, so don't worry. Household systems are often used in the home setting for administration of medications, although they are not optimal and should be considered approximations. The use of a measurement device provided with a medication by the pharmacy increases the accuracy of dosing and therefore patient safety. The household system is not used in hospital settings. So this says here that you should commit these basic household equivalencies to memory. There's going to be a lot more besides these that I'll say you need to commit to memory, maybe even more important than some of these, but that is what the book recommends. So some points to remember. The household system, again, uses fractions and Arabic numerals. Teaspoon and tablespoon are common household measurements. For patient safety, household utensils should not be used except when absolutely necessary. Household utensils are only approximations. For correct dosing, use the measuring device provided with the medication. So there's some practice problems A that you can do for your own practice, but unless it's an assignment in Canvas, you do not need to complete it for grading. The metric system of measurement is the most widely used throughout the world and is the most commonly used system for measuring medications and dosages because of its accuracy. Most prescriptions are written in the metric system, and most liquid drugs are administered using this system. The U.S. Pharmacopoeia considers the metric system the appropriate system for use on drug labels. Medication labels should be written in the appropriate metric units. Some medication labels include household units as well as metric units, as seen with the label for zidovudine in figure 4.1. So you can see here they have each 5 ml is equal to 1 teaspoonful. Additionally, some labels still contain non-recommended abbreviations such as micrograms found on the labels for digoxin and cc, which is equivalent to milliliters. So here on the digoxin label, we have micrograms. That's not recommended to use on drug labels, but they have. The metric system is based on units of 10. The basic measurements are the gram for weight, liter for volume, and meter for length. Prefixes for the base measurements are used to indicate the multiple or submultiple of the base that is being described. Figure 4.3 illustrates the following prefixes. So we have micro, milli, centi, deci, deca, hecto, and kilo. And the basic unit of measurement right here is either going to be, can either be meters, liters, or grams, depending on whatever you're doing. And I just talked about, okay, so for the prefixes, deca is 10 base units, hecto is 100, and kilo is 1,000. Deci is 1/10 of the base, centi is 1/100th of the base, milli is 1,000th of the base, and micro is 1/1,000,000th of the base. Those are submultiples. And then table 4.4 applies these prefixes to weight, volume, and length. So here we go. This is a good table. So kilogram, hectogram, decagram. And then over here we have milliliter, deciliter, kiloliter. And then table 4.5 is going to show metric equivalents used in pharmacy. So common equivalents are listed here and their unit of measure. So the most commonly used prefixes in pharmacy are micro, milli, and kilo. A cubic centimeter is another way to express a milliliter. 1 cubic centimeter is the amount of space that is required to hold 1 milliliter of liquid. The abbreviation CC is not recommended because of the danger of misreading it as 00, but it is occasionally still found on prescriptions and medication orders. The preferred abbreviation is milliliter, so pay attention to that. The M is lowercase, the L is uppercase. The abbreviation of microgram may be misinterpreted as milligrams, causing a 1,000-fold error. The preferred abbreviation is microgram. A gram is about the weight of 2 large-sized paper clips. A liter is about the size of a quart container. A meter is a little longer than a yardstick. Fractional parts on the metric system are used with decimals. So a 0 called a leading 0 should always be placed before a decimal when the number is less than 1 to prevent confusion and a possible error of interpretation. So here, if you have the strength 0.25, you cannot just write 0.25 because it could be misread as 25 milligrams. And that potential error would be 100 times too much medication being administered to a patient. Also, no zeros called trailing zeros should be added to the end of a fractional proportion after a decimal point. So for instance, 2.50 milligrams should be written as 2.5 milligrams, and 1.500 liters should be written as 1.5 liters. Zeros found at the end of a number to the right of the decimal point may be removed without changing the value of the number. The following picture depicts the weight measurements used in pharmacy from largest to smallest. There's a 1,000-unit difference between each of the following measurements of mass. And here's some more that they say you should commit to memory. I definitely agree with these for sure. So some points to remember about the metric system. It's a system of place values, with the base being the unit from which all place values are measured. The gram, meter, and liter are at place 1, or the base site. Kilo is at place 10 to the third, the thousandths place. Milli is 10 to the negative third, the 1,000th place. And micro is 10 to the negative sixth, the 1,000,000th place. When using the metric system of measurement, the numeral is right before the abbreviation for the quantity, with the full space between the number and abbreviation. All fraction parts are written as a decimal number. Be sure that any number with a value less than 0 has a preceding 0 before the decimal point. Any unnecessary or trailing 0 should be eliminated. Avoid using a decimal number if a whole number can be used, meaning like you shouldn't do 5.0 milligrams. You just do 5 milligrams. Here's some practice problems. The apothecary system is one of the oldest systems of measurement, first used by an apothecary and early pharmacists. The system is gradually being replaced with the metric system. In ancient times, a minimum of water was considered to weigh the same as a grain of wheat. Therefore, the basic unit of liquid in the apothecary system is a minimum, and the basic unit of weight is a grain. Apothecary measurements of volume, such as minimums, fluid drams, and fluid ounces, are still found on some pharmacy bottles and medication dispensing cups, even though the use of these measurements is discouraged. Those apothecary symbols are found on the ISMP list of error-prone abbreviation symbols and dose designations. Although the metric system is preferred, the apothecary grain is still used with some older medications, such as nitroglycerin sublingual tablets. So 0.3 milligrams and 1/200 grains. In the apothecary system, lowercase Roman numerals are used for expression of numbers 10 and below, rather than Arabic numerals as found in the metric and household systems. The Roman numerals should be expressed with the lines placed over them to tie them together. So such as 1, 2, 3, 4, and 5. And X with a line over top of it, that's 10. And lowercase i's are often expressed with the dots above the line. Arabic numerals may be used for numbers higher than 10, except for 20 and 30, for which Roman numerals are required. Over the years, the use of the line over the Roman numeral has gradually diminished, but using it is correct. Fractions other than 1/2, which is SS with the line over top of it, are expressed using Arabic numerals. Roman numerals and Arabic numerals are never used together in one measurement. So when using a fraction other than SS, use Arabic numerals for the whole number as well. So if you have a number that doesn't come out whole, you're going to use, unless it's 0.5 or, 1/2, you're going to use the whole number instead of these symbols. So therefore, 7 3/4 would be 7 3/4, not VII 3/4. Decimals are not used with the apothecary system. The unit abbreviation is written first with Roman numerals placed to the right of the unit of measurement. So this one's backwards compared to every other one. So for example, 5 ounces is written as the ounce symbol and V for 5. And 10 drams is the dram symbol, that little 3 looking thing with an X. We'll go over these in just a minute. So we have volume, liquid. We have the abbreviations. So minimum is an M. Fluid dram is that little 3, weird looking 3 with fluid in front of it, FL. Fluid ounce. So ounce is the little 3 with a Z on top. That's what it looks like to me. And then FL. And then grain is GR. So remember that that's, when you see GR, that's grain. A lot of students get that confused for grams. Grams is G. Sometimes people use GM for grams, but never GR, that is grains. So you can see here the dram symbol, the ounce symbol, and then of course pound. So some points to remember: the quantity should be expressed in lowercase Roman numerals, frequently with a line placed over the entire numeral and a dot above the line with the numeral 1. Although this line is not used as often as it should be, an amount greater than 10, other than 20 and 30, may be written in Arabic numerals. Numbers less than one are written as fractions, except for 1/2, which is written SS with a line over top of it. Do not combine Roman and Arabic numerals in the same measurement. The symbol abbreviation is written before the quantity. All right, so now we'll go through some example problems. Okay, so now we'll do some examples from various practice problems in the chapter. So this first part here, they're just wanting to know the equivalents for 1 cup and 1 tablespoon. So the 1 cup to ounce and the 1 tablespoon to teaspoon. And if we go to our book, that is going to be right here. So 3 teaspoons is equal to 1 tablespoon, and 1 cup is equal to 8 ounces. The next part, they just wanted you to write out what those abbreviations mean. So for mg, it's milligram. For L, it's liter. For ml, it's milliliter. And for mcg, it's microgram. For the next part, going over the apothecary system and what these mean. So this first one, this is fluid, for the FLs for fluid. And then this is the ounce symbol. So we'll do fluid ounce. The M is for minim, and this is all in the book too. The pound sign is for pounds. The FL, fluid, and that symbol is the dram. Excuse my handwriting. And remember, GR is not gram, it is grain. So just a little overview. The dram symbol is that little weird looking 3. It can either just be the dram symbol, or if it's fluid, you put the FL in front of it. And then the ounce symbol is basically the dram symbol with like a little Z on top of it. And that again can be for fluid or for solid.